Okay, today we are going to derive the magnetic field due to a circular coil at the center of the coil. Okay, now we are going to find the magnetic field due to the circular coil at the center. Okay, magnetic field will be due to what? The magnetic field will be due to what? Due to current. Yes or no? Fine. Magnetic field will be due to a current only. Yes. Right? Okay. If it is so. Alright. Now, how we can find out the magnetic field at the center? See, other places also we can find it out. But that is a very complicated case. So, we are going to start with this most simple case. Okay. Say, this is a circular coil. And this circular coil has a radius of, say, it's A. Okay. Now, how we can find out the magnetic field? Magnetic field we can find it out by means of what? We can find it out by means of the Biot-Savart law. This is the only means so far we have to find out the magnetic field. Right? Fine or not? R cube, where R is the distance, right? In this case, the distance from this of this point is what? A, right? Now, we have one thing we also know that Biot-Savart law holds good for the elemental length only, right? It's hold good only for the elemental length. So, what we are going to do, these loop, we are going to divide it into a number of small sections. Say one of the section is DL. Let's say this is very small and this section say it is DL. Now what is the direction of DL? We said the direction of DL is along the direction of current. Now at this point, what is the direction of current? Here the direction of current is like this. Right? I think the arrow, this is the direction of current, right? So what is the direction of DL? The direction of DL is along here, right? Fine or not, right? Due to this elemental section, this is the direction of DL. Direction of DL is along the current direction, right? Now, what if I use the Biot-Savart law? Due to this elemental section at this here, then the Biot-Savart law will be what? This is equal to, okay, magnitude only. So what it is? Mu 0 by 4 pi, magnitude only, right? I, D, L, R in place of R, what is the distance? It's A. Sine of, what is the angle between DL and R? What is the angle? This is the angle. Right or not? DL is along here. The distance is along here. What is the direction? This is 90 degree. Sine of 90 degree. Divided by what? A cube. Then A cube and this. So magnetic field is across. This is what? Mu 0 by 4 pi. I DL sine 90 is 1. A. This is what? A square. Right or not? Right? Now coming about what is the direction of magnetic field. Now there are two ways. Right hand thumb rule you can use. Screw rule also you can use. If you use the screw rule, then what? We need to make the rotation from DL to R. Right? Right. Right? Here. So what? Going inward. Or if you use the thumb rule, what? Hold this way. What is the direction? Inward. So, what is the direction of DB? It is inward, right? It is inward. Inward is shown by one dot. Oh, sorry. Inward is shown by cross, right? Now, similarly, let us use the Biot-Savart law even for this elemental section. Let's say for this section also. If I use for this section, what is the direction of DL? This is the direction of DL, this is the direction of A. What is the angle? This is the angle, 90 degree again. And what is the direction of magnetic field? Inward, right? Due to this section, what is the direction of magnetic? Inward. Even Even this section also. What is the direction of magnetic field? Inward. So at the center, every time the magnetic field is inward, right? The direction is the same due to each elemental section. So due to each elemental section, what will happen to the magnetic field? All the magnetic field will get added up. Understood? The direction is the same. So what is the total magnetic field? B at center? B at center will be what? Our mathematical method is what? Integration. What are we going to integrate? We are going to integrate the variable, right? So this is equal to what? Mu 0 by 4 pi. What is the variable? dl is the variable, because we have to use the Biot-Savart law along the length of the loop. Along the length of the loop, right? So this is what? Ia square, what? Integration of dl along the length. This is what? Perimeter of the loop, right? So what the b will be? This is will be what? Mu 0 by 4 pi, right? I by a square. Then this is what? This is 2 pi a, right? It cancels out. So what is the magnetic field? The magnetic field is, right? This is, okay, 4 pi, this. You can see the mathematics, alright? Then this will be what? This will be mu 0 I by 2a. This is the expression. You can even check it in your notebook also. The magnetic field at the center of loop is given by the expression mu 0 I by 2a, and the direction of magnetic field is inward. Alright. If the direction of current is reverse, then the direction of magnetic field will be outward. Okay. Now, if there are n number of turns, like there are, let's say there are small loops, same radius loop. If there are n number of loops, then what will be the magnetic field? B is equal to mu 0 Ni by 2a. This one you can check your note. Okay. Fine or not? Alright. It's clear or not? Mu 0 I by 2a. Okay. Now, so you need to remember this expression, or if you don't know the expression, you can derive it also. So anyway, it will work. Okay. Now, suppose this is half loop. Say. Alright. Say the radius is, still we are choosing the radius it as a. Alright. Okay. Now what is the magnetism? If the current I goes through it. Due to the full loop, what is the magnetic field? It is mu 0 I by 2a. Right? Due to half loop, what will be the magnetic field? Due to the half loop will be, the magnetic field will be what? Half of it. Right or not? Right? Fine or not? If the loop is quarter, if the loop is of quarter length, alright, then what will be the magnetic field? The magnetic field will be quarter of the original. What is the original? Original is this one. Now quarter of it means what? 1 by 4th of it. Yes or no? Clear or not? Fine? Okay? Alright. Fine. So if we can even find for half loop, quarter loop based upon this equation which we have derived. But say if this is a loop, alright, and say this is the radius, say this angle is theta, this is A, alright, and this is the length AB. Say the current is going this way. How to find out the magnetic field at here? Can we find it out or not? Okay. We cannot use that relation B is equal to mu 0 I by 2A. Yes or no? Because that formula is valid for full loop. This is not the half loop. This is not the quarter. It is of some angle. Right or not? What to do? How to do? We have to use the Biot-Savart law again, because magnetic field can be found out by means of Biot-Savart law only. Alright. So let me write the Biot-Savart law again. This is equal to I dl. Okay. this is A, then this is A cube, right or not, right? Then magnitude also we can quickly write it down, right? Magnitude is mu 0 4 pi I dl by A square, right? Fine or not? Now due to this, right? Due to this, then what we need to integrate it, right? If we integrate it, this will be what? Integration of dB is equal to what? Mu 0 by 4 pi I by A square integration of dl, right? Okay, do you know that if this is an r, if this angle is theta, this is radius, and this is the length, do you know the relation that r theta is equal to length? This is a formula in class 10 you might have learned. If you haven't learned, now you need to know. Radius, angle and the arc. The length of the arc is equal to radius into the angle containing it. Alright. Now this one, in place of this d theta, alright, in place of this dl, because dl we are choosing the general, right? So b is equal to what I can write? Mu 0 4 pi I by A square dl. In place of dl, can I write in A theta? Integration of A theta, right? Alright, fine or not? Okay, let me do one more thing. Let me not do any of this. There is a simple method for this also. Alright, dB is equal to mu 0 4 pi, right? I by A square. In place of d theta, in place of this is dl, let's say, okay, or any elemental section I have chosen. Okay, this is full arc. What I can write? A theta, right? A square and A, this A cancel out. So what is the magnetic field due to this length over here? This is what? Mu 0 by 4 pi, okay, mu 0 by 4 pi I by A, okay, theta, yes or no, right? Due to the full length, right? Due to the full length, okay, dB. So this is the expression. The same thing, okay, I'm writing dB because it's small, okay, or I can write B the same way. Can I write it this one as this way? Mu 0 by 2, okay, mu 0 by 2 I by A into theta by 2 pi. Yes or no? Can I write it or not? Yes, theta by 2 pi. For any angle theta, it's this formula. If theta is one full circle, how much theta is? 2 pi, 2 pi and 2 pi will cancel out. This relation will come, right? If theta is half circle, right? If theta is half circle, then theta will be equal to what? Pi. Then pi and pi will cancel out. What it will be? Mu 0 I by 4a, right? Actually, this is the more general form. Okay, so you can look at your note and you can learn this one. What about the direction of magnetic field? The direction of magnetic field at the center is